Hi, this is Kazi from India. This is the 1/4 model of the suspension system of a bus, and EM1 and EM2 are the two masses. EM1 represents the entire body of the bus, EM2 represents the suspension system of a bus. K1 is spring constant, B1 is the damping unit, and U represents the controlling force. X1, X2 are the displacements, and W is the force which we get from the road or from the pothole. So that is W, a signal which you are giving. These are the values just to understand the system parameters. On deriving the equations, sorry I cannot take you to the derivations, you'll have to do it in yourself, but I have the derived equations that we keep the acceleration on the left side, rest all things on the right. You see m1 into, that is m1 is the mass, into x1 double dot, that is displacement, right? Derivative, mass into displacement, mass into acceleration, so hence it is x double dot. So k1, so similarly for k2, x1 dot minus x2 dot into b1, that is damping, k1 into x1 minus x2 plus b2 into w dot minus x2 dot. So w dot represents the force or the error from the road or a pothole. Okay, so I'll be taking you to the Simulink design. First let me take out the things which I require to begin my simulation. First I'd like to take step input, then I need scope to display the results, derivative is very important, but we'll take it later. As per now, I just need a few more things, like I need an addition block, I need a gain block, I need an integrator, and I'll start arranging these things according to equations. You see we have minus, minus and plus, so we have three symbolic which represents addition and subtraction. So I'll have to double click on this add and just write minus, minus, plus. Okay, you can see the same over here. It is just representing the equation. This is what a Simulink is. And now I need a gain block. I'll find it in commonly used blocks. I'll take it from there. This is gain. Okay, if you look at the equation there, so you'll find 1 divided by m1. That is not mentioned in the equation, but actually when you take m1 to the RHS, right hand side, it will be 1 divided by m1. So just keeping that thing in mind, so the gain value would become 1 divided by m1. That is what is shown over here. You can see this m1 into acceleration, mass into acceleration on the LHS, and RHS we have equation, right? Hence if I take m1 to the RHS, it will be 1 divided by m1. So that is what I'm writing over here, and I'm using an integrator block. So here I'll just copy it, and yes, okay, so in between gain k and integrator I have mentioned the a1, which means acceleration. So when I integrate acceleration I get velocity, and when I integrate velocity I get x1. That is what is mentioned over here. So we got the equation for x1. Similarly I have to do it for the x2, right? I'll just copy this, and I'll change the names to a2, v2 and x2. Remember, keep one thing in mind, that this is for the 1/4 model of the bus. That is, this is for just one tire suspension system. Then I'm not going to show this for 4 tires. Okay, and according to the equations, you'll see we have 1 plus, 2, 3, 4 and 1 minus, so totally 4 plus and 1 minus, right? So this is how I have to change the addition sign to minus minus, sorry, minus plus plus plus. Okay, I'll enlarge it now. Okay, it's very interesting now. I have x1 value, x2 value. Just I have to go through the equations, and according to equation 1, it is minus b1 times x1 dot minus x2 dot, right? So I'll take x1 times, sorry, x1 minus x2, so x1 minus x2 times b1, that's what is according to the equations. And I'll have to take an addition block. Okay, I'll take the addition block from this math array, and I'll take the gain block first, and I'll take addition block. It is very important. I'll use Control R, that is rotate, so that I can rotate it. Okay, and I'll have to take addition block. Addition block is also available in this commonly used blocks, or you can even go to this math operations. So in the math operations you'll get it the addition block. So here I'll again use Control R to rotate. Okay, and the equation was b1 minus x1 dot minus x2 dot. So x1 dot, I get it right after the first integrator, so that is x1 dot, that is velocity, and this is x2 dot. And you know that x dot represents velocity, x double dot represents acceleration, right? And let me do it for b1, and you can even see that the first equation, it is for minus, and the second equation, the same equation, is for plus. So keeping these things in mind, I'd like to change this thing to b1 from here, and you can even see for the second one, that is x1 minus x2 times k1. So I'll use Control R to rotate, and x1 minus x2 into, I'll take this, you can just right click on your mouse and drag it, the particular block will be copied, and I connect it over there. And I would like to change that v1 block to k1 now, because it is x1 minus x2 times k1, so this is k1. Okay, and this k1 goes to the negative sign, because you can see it's minus k1 times x1 minus x2, and similar it's plus k1 times x1 minus x2 on the second equation. So the same signal goes to minus sign for the first equation and plus for second, right? Just arrange this. It should be clear, that's all, so that you can understand it, right? I'll make this and connect this to this end, right? So the first equation is done. It's time for second. Okay, if you look at these equations, yeah, I'll come back again. I need derivative now. It's very important. Derivative. Why do I need derivative? Because if you look at the equation number 2, we have w dot, x2 dot, right? So for that, I'll take w as the step input. So this w is the pothole error, right, which I get from the road. So whenever the tire just goes into the pothole, I'll get a signal from that. So I represent it through a step signal because it will be just one step, right? It is just produced at the moment, right? Hence it's one step signal. And if you look at the equations, it is like w dot k minus x x2 dot, w dot minus x2 dot. I'll get it right after first integrate. Okay, and into it's b2. If you look at the equation, it's b2, w dot minus x2 dot into b2. I'll just right click my mouse and drag it, control R to rotate, or you can, if you're comfortable with this, you can even, and I'll just change it to b2 and I'll connect it to the plus sign of this. It's right now. Yeah, I think oh sorry, I think I'll have to take it down. Yes, now this is fine. This is fine. Now I have another equation. I have another element left in an equation, that is x2 minus x1 times, sorry, it's w minus x2 times k2, right? Oh, I'm very sorry, but I think it has to be plus and minus, right? Yeah, but most of the I have used it as plus plus. I'll have to change it. It's w minus x2, right? It's w minus x2. Change it. This goes to x2. This comes to w. I think it's fine. I'll just take it down. Yeah, this is okay. This is okay, and this is equivalent to k2 times, right? So I'll just take it, control R to rotate it, and yeah, this is k2. Instead of b2, I'll have to change it to k2, and this k2 goes to the last addition symbol of this adder. Okay, I'll have to change this plus minus because, you know, I just forgot to change the symbols, the addition. Extremely sorry. It's plus and minus over here, and yeah, one more left here. It's plus and minus. Yeah, done with that. Right, so what else is left in the equation? If you look at the equations, we are left with only one more very important step. You are just one step away, sorry, two steps away from getting the output. That is u. U is the controlling input. I give it as a step input over here, and the same u is being given as a negative signal to the second equations according to the equations being derived. Right, I'll take this curve and connect it over here. Yes, because this is x1 minus x2, that is what is the final displacement, and I'll paste these values, right? These are the values, standard values, just I'm using it for the sake of testing. You can take your own values, right? And when you run this model and when you double click on this, you'll see this. So these are the signals for suspension open loop system, right? So in the next video I'll continue with the closed loop system, the same model. It's a very interesting model. Okay, hope to see you back, and please share your email ID to get the Simulink file. Thanks for watching this video again. Thank you.